Hey everybody, so this video is about analyzing trusses, and we're going to focus on the method of joints. So you should see that other video first about the method of joints. Here I'm going to show you an alternative starting point for the method of joints. So this is the same example from the other video, and a quick walkthrough how you would use the method of joints. For each joint, you just go joint to joint, draw the free body diagram. So for example, joint A. I got these two axial forces, AC, AB, and then the reaction at the pin support. So if I pick a coordinate system, then there would be reactions at the pin, which I will decompose into X and Y components. Okay, so here's the free body diagram for joint A. For joint B looks like this. So there's axial force BD, BC, AB, and then there's a roller support, which is normal to the surface that it's rolling on. Okay. Now for joint C over here, I'll just draw it right here. So there are three axial forces, AC, BC, CD. Okay, and then joint D is over here. I'll just draw it right here. So there's this beam and this one, and the 2 kilonewton load here. Okay, so 4 joints, 4 free body diagrams. For each free body diagram, you can write 2 equations. Right, for each one, you can write 2 equations. Now, here's an alternative starting point. You can look at the structure as a whole, the whole thing. So let me copy this. So instead of drawing the free body diagram of each joint, I'm going to draw the free body diagram of the whole structure. So I don't care about the individual members, like this one, this one, this one, this one, and this one. I don't care. It's just one structure. And all I know is for that one structure, there is a pin support. Let me draw my coordinates over here again. There's a pin support at A, which I will decompose into components. There is a roller support at B here. And there's a 2 kilonewton load here. Okay, so this is the free body diagram of the entire structure as a whole. Now, I can write 3 equations to solve for these 3 unknowns. Here, some forces in X, some forces in Y, some torque about any point I want. Here, 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 wherever you want. I'm just going to say over here. So I'm going to sum the torque about point A. Okay, so about this point, this force doesn't produce any torque. This does not produce any torque. This one does. And that's the lever arm here is 6 meters. And that's going to create a torque about point A this way, counterclockwise, which is in the Z direction, right? If X is here, Y is here, that means Z is out of the page, counterclockwise, so this is positive. And then this force produces torque about this point. The lever arm is this much, here to here, so that is 10 meters. and that will produce a torque clockwise about point A, which is in the negative z direction. And is that everything? Yep. Okay, so now look, 3 equations, 3 unknowns. Solve this for B, right? B is 20 kilonewtons over 6 meters. 20 kilonewton meters over 6 meters. And then solve for AY, 2 kilonewtons, and then solve for AX. So now you have all 3 of these. Now we go back, well, I was saying this is a starting point. So you would start here, solve the 3 equations for the 3 unknowns. So at this point, you know the 3 reactions. Now you can do the whole joint to joint. But we know these answers right here. Right, so then if you look at it, this free body diagram has 2 remaining unknowns. And we can write 2 equations, which means you can solve for these 2. And then once you go there, you know this answer, which is the same as here. You know this answer, which is the same as here. So now where do you want to go next? Joint B or joint C? Either one, because this has 2 unknowns and this one has 2 unknowns. So either choice. So let's say we go here. 2 unknowns, 2 equations, solve it. See right here, BC is the same as this one right here, BC. See up here, BD is the same as right here, BD. So now where do you want to go next? If you go to joint C, we only have 1 unknown left. And you can write 2 equations. You don't even need 2, you just need one of the 2 to solve for the remaining unknown. And then the last joint here at joint D, you got 1 remaining unknown left. And you can write as many as 2 equations. You don't need both, you just need 1. Okay, so that's the alternative starting point. So one way is just go joint to joint, write all the equations, and then you don't need to do the whole find the reactions at the supports. You can just go joint to joint because this has 2 unknowns, so solve those 2 first, and then go here, because you would know this answer from right here. So 2 unknowns, and then you would know this answer right here from here, and this one here from here. So there's only 2 unknowns here, solve those 2, and then you would know this one from here. Oh, sorry, from here. This one from here. It's getting messy. 2 remaining unknowns. Or you can do start with the reactions at the supports and then go joint to joint. So either way, it's good to practice both ways. So give those a try, and then if you have requests you'd like to see certain problems solved from the book, just let me know in the forum and I'll record videos of those. Okay, so keep on practicing. I'll see you on the next video.